Well, the tender started about 6 years ago, and obviously that's where the client gave us the challenge. So listen, we want to see something different, and that was the challenge in itself.
Balfour Beatty developed this machine and patented it, and this is I think one of the first ones in the world we know which can actually install the cable in this way.
The thing that makes me proud about this project is we've actually delivered this project. It's on, for the cabling aspect of it, it's on time.
We no doubt have set a precedent in the method of installing cables by reducing the number of people down in the tunnel environment, which is a confined space, and also by reducing the tension on the cable itself. We've improved not only the safety but also the technical installation aspect.
Croydon Cable Tunnel project, in terms of the cable installation, has involved several key aspects which have seen how we've improved the method of doing this sort of work. Initially, the actual delivery of the drums, the movement of the drums around site using a trailer, which actually is then deployed with the cable on the back to feed the physical cable into the tunnel system. From that point, we've then got a mechanised cable pulling machine which actually then pulls the cable pretty non-dynamically down the tunnel and delivers it onto the brackets in the actual tunnel environment. That is a major improvement in terms of what we've seen before as to methods of installation.
If you look at the cable weighs about 30 kilos a metre, and before you would have say 5 to 10 guys over a 10 or 15 metre span pushing a cable or manual handling it. Where you actually lift the cable into position, the machine does it for us. So basically all you're just doing is actually pushing, okay, if you need to, but the machine takes care of that. So that's actually drastically cut down the labour we require in a confined space.
Traditionally, cables were installed using a series of winches, and these have quite a high stored kinetic energy. By using the cable pulling machine, we were able to remove that risk.
With the machine, we found there's plenty of capacity, even when we install this almost 1.2 kilometre section of cable, which is essentially the longest ever been pulled in the UK or Europe to our knowledge. When we designed the original machine, the intent was always to use a battery operated machine. But during the early stage, we had no real knowledge in terms of the pulling power required for this machine to pull about 50 tonne of cable into the tunnel. For us, the biggest challenge was using a diesel engine on the ground.
That was the biggest challenge we had, and luckily within Balfour Beatty opcos, we have a Balfour Beatty plant who have a number of years of experience working within LUL, London Underground, and other tunnels. So part of their remit was to be at the design stage to look at all the legislation and all the hazards and tick all the boxes before we could go down the route of designing this engine, which is a diesel engine.
The actual design of the machine took about 2 years, basically from looking at the detailed design of the machine up to the delivery of the machine. The machine changed significantly from the one you've seen today to the one we originally had on paper. Just basically functionality. You always see, once you delve into the project itself, the requirements, especially safety for operators, that's where you need to make a change here, you need to make a change there, and obviously as you get more changes, the machine grew, more functionality, more safety features.
This particular machine was designed for use in the 3-metre tunnel, so by modifying it either slightly larger or by making it more compact, we would quite comfortably be able to install a second circuit adjacent to a live tunnel.
Also, another major task to manage is actually getting the drums from the laydown area into position and obviously into the tunnel. And what we found is the laydown area compared to the position where we're going to pay off the cable was quite a distance apart. And when you look at these size of drums, you look at 50 tons drums, so there's a lot of weight you've got to transport across site. The general way in doing this is obviously using huge mobile cranes in the order of 300 ton cranes. And we looked in the industry, and there is a lot of accidents with cranes. So we looked at developing a bespoke cable drum trailer, basically used to transport drums in and around site. So this drum trailer can pick up drums, you can pull it with a tractor into position, and you can use it as a drum stand as well. And by using this, we actually saved 54 crane lifts, which is not only a significant amount of money, but you're reducing a lot of the hazards on site, or potential hazards.
Once the drum's on site, we take them to the point of installation, We have a bespoke method, again, using electric rollers and caterpillars, which controls the cable from the drum onto a monorail system.
The monorail trolleys run on a monorail inside the tunnel. The biggest challenge for us there was actually developing a braking system for these trolleys, because you've got to bear in mind the tunnel is at a slope on a 1 in 100 angle, so the nose of the cable is going to be 10 meters lower than the tail of the cable. So you imagine how you restrain 50 tons of cable hanging down. So what we've designed is a special monorail trolley that we position every 10th trolley, and this almost works like a caravan system. So you can't move the train, you've got to actually pull on the train and then the brakes release, so then the system can move forward. Should the machine break down or anything and the machine stops, the whole trolley system will stop, and that's the safety feature in itself, makes sure the cable doesn't run out of control.
It's just like you draw a curtain at home. When you pull a curtain, that's what the cable's like. So you've got wheels on the monorail itself, just like a curtain you've got at home, and in between that you've got sags. So when you draw your curtain, that's all you're basically doing with the cable, but it's just a 52-ton cable, it's 1,200 metres long. So basically it's a giant curtain rail pulling the cable.
When it comes to laying off the cable, the key things on the machine is a mechanical arm. It's a basic hydraulic arm operated by the operator in the operating cab, and it grips around the cable, and as you move forward across the cable, this arm actually weaves the cable into position. This arm obviously works with the wrist, it's got an elbow, so you've got very good control in where you position the cable, where you lay the cable off, and obviously the position as well. The arm's got rubber grippers, so obviously there's no chance of damaging the cable, and obviously when you close the cable, we've got pressure sensors, so you basically limit the tension on the cable itself. The key thing about the machine doesn't need to be turned around the shaft when you're installing in either one direction or the other. This is a symmetrical machine. You've got arms on both sides of the machine, and you've got operator cabs on both sides of the machine with an engine in the middle. So you can use cable installation either forward, reversed, or from the right side of the tunnel or the left side of the tunnel.
Further back then is the workstations, and in each of these workstations there's an operative. Once the cable is offered onto the brackets and sagged appropriately, these gentlemen lean out and attach the brackets which hold it in place.
The features obviously on the machine itself, as well as the less people using the machine, once the cable is on there, it's a very quick way of taking the cable to the point of installation. If you were using traditional methods, which is the winch one, every 1.2 kilometre we'd have to wait, reposition the winch, fix everything to the tunnel, pull the cable. So a 7-kilometre movement of cable would take you a number of days. With this machine, we've done it in a number of hours.
The cable pulling machine is first and foremost incredibly safe. We've got fewer people down into the tunnel. It's also kinder to the cable in that the pulling tension is reduced. The next benefit of the cable pulling machine is the ability to install a second circuit and to use it in various diameter tunnels.
We have not only improved the safety aspect, we've actually seen quite impressive delivery rates and program benefits from using a mechanised method of installation.
The machine has been used successfully. We significantly reduced the number of operatives on the machine. It's significantly safer. And one of the key things is also the cable care, because at the end of the day, this cable is a lot of money to the client, National Grid.
You know, I've had some experienced guys on here, some of the guys 30, 40 years, and they've evolved from bond pulling to actually pulling like this. It's when they come to you and say, that works, and that's a great machine. I can't believe I'm using it with less guys.
The cable tunnel project set specific challenges to the teams that were involved. That wasn't just the suppliers, that was the client, everybody involved. And one of the big challenges was Shez in terms of the physical improvement in safety and the environment that workers have to face when they get down into these cable tunnel environments. And the mechanised cable installation system has achieved that.
And I think it's going to be the future way for installing cables in tunnels, without a doubt, in my 30 years experience in the industry. I think this is a very, very safe and best way to pull cables.